In this approach, we use a classical computer vision approach to recognize faces without any deep learning. First, we process the images by converting them to grayscale, enhancing the contrast using histogram equalization and resizing them to a standard size. Then we extract different types of features to understand both the shape and texture of the face like HOG, SHV, SIFT and Gabor filters. All these features are combined into one vector for each image. For classifications, we used an ensemble of support vector machine, k nearest neighbor and random forest, and we combine that prediction with soft voting to get the final label.
First is the preprocessing function. It converts image to grayscale, uses histogram equalization, resizes image to 128 into 128 and converts back to RGB for consistent input format. Then is the load image function, which converts BGR to RGB because OpenCV loads in BGR. It calls a preprocess face function to standardize and enhance the image. Then feature extraction function converts to grayscale to simplify feature extraction. For that we have used different methods. HOG, Histogram of Oriented Gradients, captures edges and gradient directions highlighting shapes of eyes, nose and mouth. Local binary patterns captures texture patterns like skin wrinkles and robust to lightning variations in neutral 1 and neutral 2. Then is HSV histogram. It captures color distribution using HSV, hue, saturation and value. It is useful if skin tone or lightning helps distinguish faces. Lastly, SIFT detects key points in the face that are stable across scale and notation. It is used to identify unique facial landmarks. Last is the Gabor filters. It captures facial texture patterns in multiple directions. Here we store the mean and variance of filtered image as features. Lastly, we have combined all the features into one single feature array for each face. This is the loading dataset function. It calls load image and extract features for each image to load images from a folder. It keeps track of features, labels and file names. If a label exists in CSV, it is assigned, otherwise none. Then is the paths and labels. Defines paths for train and test images from my own laptop and reads training labels and ensures column names are consistent. Loading training and test data. It loads training features and labels. It ignores the none entries and loads test images without labels. Cross validation is done by k-fold cross validation method, which ensure all the classes are represented in each fold. It helps evaluate model performance reliability. Next is the SVM grid, which uses grid search CV, finds the best SVM parameters automatically by building a pipeline with scaling power transformation. Then is the ensemble voting classifier. It combines SVM with k nearest neighbor and random forest into ensemble, assigns more weight to SVM. Then is the prediction images. If feature extraction fails, it assigns the random leftover label from training set and ensure all 216 have predictions, then saving the output file.